Hey everybody, in this video we're going to be looking at related rates problems and using derivatives and implicit differentiation to solve these types of word problems. Now we've covered all the steps necessary to solve these types of problems in the previous video. So let's say we're given a 10-foot ladder that's moving down a wall. When the ladder is 8 feet away from the wall, it is moving at a rate of 4 feet per second. How fast is the ladder moving down the wall? So let's figure out what are we trying to find here. Well, we're trying to find dy over dt. So essentially we're trying to find the rate of change of the vertical distance with respect to time, which the vertical distance is the distance between the top of the ladder and the bottom of the wall. So let's actually visualize this because it may sound a bit confusing. So we know that the length of the ladder is 10 feet. That's never going to be changing because the length of the ladder is obviously going to stay constant. In this specific moment, the horizontal distance from the bottom of the ladder to the wall is 8 feet. And we know that the rate of change of the horizontal distance with respect to time is 4 feet per second because that's given in the problem. And we're not sure what the vertical distance is. All right. And we're trying to find dy over dt. So first, let's write an equation relating these variables together. We can use the Pythagorean theorem. So x squared plus y squared equals 10 squared. And let's find the derivative of this with respect to time. So remember from the implicit differentiation video, we have to implicitly differentiate this equation. So we get 2x, which is the power rule, 2x times dx over dt, because the derivative of x with respect to time is dx over dt, plus 2y times dy over dt equals 0, because the derivative of 10 squared is 0. Now you might be wondering, why did we not plug in 8 for x? Because we got that, right? But the reason why we cannot do that is because the x variable is always changing. All right, so we can plug in 10 because the length of the ladder is always going to be 10 no matter what. But we cannot plug in 8 for x because as the ladder is moving down the wall, for example, the horizontal distance would be changing. So we can't plug in 8 for x. All right, so let's say we have this equation that we can use, which we will utilize a bit later. But let's say we want to figure out in this specific moment, let's write an equation for it. All right. So in this moment, so in this scenario, we can actually plug in 8 for x because we're talking about this specific moment. All right. So make sure you specify that so you don't get confused. 8 times 4, which is dx over dt, plus y over dy over dt equals 0. And we want to find y at this moment. So we can just simply do that by using Pythagorean theorem, right? Simple Pythagorean theorem, we have 10 squared equals x squared plus y squared. We can figure out that y equals 6. We plug in 8 for x, we figure that out. All right, now we can plug that y in back in the previous equation. And we get 8 times 4 plus 6 times dy over dt equals 0. We can isolate dy over dt and get negative 32 over 6. Now we can say in an entire full sentence, at this moment, or you can say, when the ladder is 8 feet away from the wall, the rate of change that the ladder is moving down the wall is 32 over 6 feet per second. Now, you can say the rate of change the ladder is moving vertically from the wall is negative 32 over 6 times negative 32 over 6 feet per second, but it makes more sense to say that since it's a negative number, obviously that would mean that the rate of change leads to the ladder moving down the wall instead of up the wall. Also, that makes the most sense, right? Why would the ladder move up the wall? All right, hopefully that makes sense. Comment down below any other math topics you want me to review. Thank you.